When it comes to case control studies, we use an odds ratio, which is often abbreviated as an OR, as the measure of association. This measure of association is essentially telling us information about the frequency of exposure and the frequency of outcome in our case control studies. So what it is it is a comparison of the odds of exposure in the cases compared to the odds of exposure in the controls. All it is a fraction. A fraction that in the numerator includes the odds of exposure in the cases, and in the denominator includes the odds of exposure in the controls. We use an odds ratio, which is essentially an indirect measure of association. When it comes to case control studies, we do not use direct measures of association. So for example, incidence rates. We typically use incidence rates in the relative risk calculation. These are really intuitive, right? They tell us in a period of time how many people developed a given disease or health outcome over that period of time. When we have something like a cohort study, we can observe over a period of time how many people ended up getting the disease or the outcome of interest. We calculate a relative risk, which is essentially a fraction of incidence rates. However, in a case control study, we cannot observe the incidence of disease. Instead, as the researcher, we are going out and identifying people with the disease and then identifying a similar comparison group of controls without the disease to compare those cases to and assess their past exposures. So let's think about this a little bit differently. Let's say that we went out and conducted a case control study to study something rare like ovarian cancer. And let's say that we went into a healthcare facility and we identified 50 patients with ovarian cancer from their medical records. And then we found 50 comparable controls that don't have ovarian cancer. Our total sample is 100 people. We wouldn't conclude that the incidence of ovarian cancer is 50%. That would be absurd, right? There's no way that 50% of a population could have ovarian cancer. Something would be drastically wrong. Ovarian cancer is a very rare disease. The challenge here is that in a case control study, as the researcher, I am going out and picking the people who are in my study. Therefore, I cannot observe incidence rates in that particular group of people. So instead, I can't measure incidence. Therefore, I use an odds ratio, this indirect measure of association for a case control study. As I mentioned, an odds ratio is essentially a fraction, right? It is a fraction that compares the odds of exposure in the cases versus the odds of exposure in the controls. And so instead of memorizing formula, I want you to actually understand what you're doing when you calculate an odds ratio. So again, it is going to be the odds of exposure in your cases divided by the odds of exposure in your controls. So let's start with the cases. The odds of exposure is just going to be A over C. The number of people who were exposed divided by the number of people who were not exposed. That's A over C. And then I'm going to divide that by the odds of exposure in the controls. So divided by B divided by D. That comes out to A divided by C, then divided by B divided by D. That mathematically works out to this AD over BC calculation, but I really advise not just memorizing that because you don't actually understand what you're doing. I would actually calculate it out like this, where you're actually writing out those numbers A over C, and then dividing that by B over D, because then you are actually comparing the odds of exposure in your cases versus the odds of exposure in your controls. In terms of interpreting an odds ratio, if it is not due to chance, meaning that we have found that our results are statistically significant, then we can conclude that an odds ratio greater than 1 suggests a positive association between an exposure and a disease. An odds ratio less than 1 indicates that the exposure might be a protective factor. So if you have an odds ratio greater than 1, you potentially have a risk factor, while an odds ratio less than 1 means that there could be a protective relationship between those variables of interest. And when we have an odds ratio of 1, that essentially means that there is no association between our exposure and our outcome variable. So let's look at an example. If you have an odds ratio of 2, the way you would translate that is that the odds of exposure were 2 times higher among the cases versus the controls. Now, the measure of that odds ratio, as that gets larger, that means a stronger association. So an odds ratio of 10 would indicate a much stronger association versus, let's say, an odds ratio of 2.